Alright guys, welcome back again. Let's continue the process of building the agent, long running agent, right? And yeah, let me set up this. Now guys, we will code this. We already code the research agent and the research server, right? Right here, and after that we will code this orchestrator client. Okay, just wait a minute, just okay. Let me see where I am. Where I am in this CD. I have to go to A2A advanced like this, and in this I need to create a file which is touch orchestrator slash A2A dot client, right? Py like this. Clear? Alright. Let me code this. So purpose of this file is, so it's a file for a clean Python client for calling the research agent over A2A protocol. Okay, the orchestrator imports and uses this. Alright, and and it will handle the agent card discovery and task submission, polling, streaming, cancellation, and result extraction. Okay, it will handle all of these tasks. So let's start. First, we import async IO, right? It is used for here. It will used for async IO.sleep, right, in the polling loop. So what it does is async sleep. If we give argument as n pauses, this coroutine for n seconds without blocking the event loop. Other coroutines keep running. Okay. So after that we import JSON. So we are importing this to parse the JSON responses from the A2A server and parse the SSE event data also, right? Right, so we are alright, guys. So let's start this. Right, why we need this JSON? We need this to parse JSON responses from the A2A server and parse SSE event data. Okay, and it will what it does is we will call the JSON loads.text method to convert the a JSON string into a Python dictionary, right? So JSON decoder error is the exception raised when JSON parsing fails. This is why we used it. So yeah, right. After this, we import the time to return the current time Unix timestamp in the seconds, right? Used to calculate like elapsed time and enforce the timeouts also. Okay, this is time. This is now similar to date and time, right? This is different from date and time. Then we import UUID. Alright, why generate unique message ID? It is used to for generating the unique message ID values for each request, right? And each A2A message needs a unique ID for duplication, right? So UUID or .UUID4 generates that unique ID for us. Okay. Then we import from type thing, import optional, we import dict, import any also, and we import async generator. Okay. So these are the type hands for function signatures. Like async generator is the return type of the async generator. Okay, and function it yields dict values and return none when done and used to the stream task method. Okay, and what is this problem here? Alright, so we need to separate it by commas, right? This is not like, okay. Used to stream task methods, okay. Then we import httpx. So this is an httpx is an async http client library for Python. Okay. So what it does is it makes http request like get, post, delete to a server. Okay. Why we are using httpx, not the requests? The standard request library in is synchronous. Okay. It blocks while waiting for the response. Alright. httpx is an async client that works with async and await and doesn't block the event loop. Okay. Then when to use anytime you need to make the http calls in a async Python code. Okay. Then when that's when we use this, and after this we have this class A2A client, right? So this class we will define to encapsulate all the A2A communication in a single class. Alright. It will provide clean methods for every A2A operation. Why we are using the class, not the function? The class also shared httpx dot async client, right? The connection pool, so the methods reuse the same connections rather than creating new ones for every request. That's why we are using the class, not the function. Okay. So in this, let's define a def init, okay, self comma base URL str timeout float 300 like this. Alright. What is this saying? The constructor runs when you do a client base URL input, right? So it will store the server URL and creates the HTTP client for you. Okay. When you call this, okay, I will tell you after that everything. Okay, and self dot base this URL into base URL dot strip it by slash. Okay. It will store the URL without a trailing slash. Alright. So what rstrip does is removes the trailing characters, slash characters here. Okay, it's not a strip only, it's rstrip. Okay, so remove the trailing characters like we are removing the slash here, and alright. So what it will prevent us from? It will prevent us from the double slash bug, right? Because let's say you have a URL like https, right, localhost 8001, right, you have okay. So after this this will become let's say like https localhost 8001 only. Okay, this will become like this, and uh, this prevents us from prevents, right, double slash bug like this https server // v1 / task. Okay, so this double slash bug here is this prevent us from this, right? Okay, and then we have self dot timeout defined as timeout, and this will store the timeout for use. 300 is equal to 5 minutes, right? So 300 seconds are there. So research can take several minutes, right? A short timeout would fail here. Alright. So this is why we are making it 5 minutes, and we have this self dot client is equal to httpx dot async client. Okay, you now understand why we use this async client. Timeout is equal to timeout. Okay, so this will create one shared HTTP client for this A2A client instance. Okay, this function HTTPX async client does what it does is it maintains a connection pool and reduce the TCP connection for multiple requests to the same server. Okay, this will be much faster than creating a new connection for every request, right? Why we are initializing the client with underscore right here, right? Why like this? This is because convention for private attributes that shouldn't be accessed directly by code outside this class. Okay, that's why this private attribute this is just a queue. Oh, it's a convention. Okay. This is why after that we will define a function async def get agent card. Okay, so what is this? This is for fetch the agent's capabilities before sending any task to it, right? It will make a get request to /well-known./agent.json, right? And it will return the agent's name, skills, and capabilities as a dictionary. So we will call this to first verify the server is running and to check what skills the agent has, right? So let's do this. URL is f string of self dot base URL, right? Then after that /well known /agent.json, right? This is our URL now. Build the full URL after this. Okay, and now response is equal to await. Okay, self dot client dot get of URL, right? So this is the get function. from client. Client was this HTTP, yeah, this is HTTP get request on this URL. Okay, so why we are using await is like HTTP request are IO operations, right? That takes some time. Await lets other code run while uh, we wait for the server's response, right? And this function, what it will client that this what it will does, it will send the HTTP get request to the URL, right? After it, uh, response dot raise for status. Okay, so if the server return an error, right, like 404, 500, 404, etc., so it will raise an exception immediately rather than silently returning bad data. Okay, it will throws the httpx dot https status error for 4xx or slash 5xx responses. Let me also write it. Okay, it will throws httpx dot https status error for 4xx slash 5xx responses, right? Then after this we will return the response dot JSON, right? Parse the JSON response body into a Python dictionary after this, and httpx JSON method calls JSON loads on the response text. Okay, now it will be like, okay, it will have async def send task self dot text str. Alright, str here. This while send task, what is this doing? In this it will submit a research task and get a task ID back from the server immediately, and it will use the post server post method to slash v1 slash message semicolon no colon send with blocking is equal to false, right? Return the task ID string within the milliseconds, and it will start working in the background on the server side, right? So in this what we do is we have a URL equal to f of a string, right? Self dot base URL here. We have slash v1 slash message, okay, dot send. We are working like this. So this is the complete URL build here. So payload is equal to, we build the request body, okay, following the A2A protocol format. So you know the message body, this is JSON, right? Like it will have the message like this. We will have the message ID here, right? str uuid dot uuid4, right? This will give us the unique ID. Each message is, needs a unique ID, so it will give a 128-bit byte, I think. Okay. No, bit, I think, yeah, bit ID. And then it will as a role also, it will define its role, which is user. Alright. And we are the user sending a request to the agent. Okay, this is the user, and we have parts here, and in the parts we send this text, okay, txt, like this. Alright, like this. So wrap the research query in A2A parts from parts format right here, and A2A message use parts arrays to support multiple content types like type, text, image, file, like this, right? That's why we need these parts in one message only. Alright, and after this message we send configuration, right? It's like logging is false here, right? Because the most important field is false, because non is equal to non-blocking right here. False is allowing, it's the non-blocking. The server return the task ID immediately and without the waiting. If it is true, the server would wait minutes before responding, likely causing the HTTP timeout errors like that. Okay. After this, we have response equal to wait dot self dot client, okay, post URL dot JSON is equal to payload, right? This is our response. So post required with JSON body is here, and JSON is equal to payload. HTTP automatically sets content type, okay, application / JSON, and serialize the dictionary to a JSON string right here. And after that, response, okay, the HTTPX will this is a dictionary, right? This message payload is dictionary, so this will be converted into a JSON after that. And after this, response dot read for status, right? Let's say fails fast if the server rejected our request, right? This is give us the reach the exception error, right? Now we have data is equal to response dot JSON, right? This method is for parse the JSON response to access the task ID, right? So this JSON response, what we look at the agent ID, the task ID, and the status or state from the server, right? After this, we keep track of this task ID is equal to data task, okay, and ID. Like this, we can access that. Extract the task ID from the nested JSON structure. Okay, the server respond with task ID, task XXX status, like that. So we extract that from that. Okay. Now print f string is like this, A to A client, right? Task submitted, okay, and ID is this task ID, right? So log the task ID for debugging and visibility here, right? And we will return the task ID here. Alright, and we will define a function for task status, right? Async def get task status, okay, self task ID here, str, right, dict str comma any. This will be the return type. Alright, so this method is to check the current state of a specific task, okay, using the task ID. It will xj get method slash v1 dash task id, okay, return the task dictionary with its current state, like okay, submitted or working or complete or field, right. Then when to use it is like called, it will call repeatedly in the poll until it's complete the task. So we have this URL is equal to f self dot base URL, okay, and after this slash v1 slash tasks slash task id, right. This will give us the task dictionary, right, and it will the URL with the task ID embedded in the path, okay. F string substitution is like task ID inserted into the URL. That's why we need the F string. This will be inserted. Alright. Now response is equal to await self dot client, okay, get URL, okay. This is the get method. This will get some response from there, and if it is fails, response dot raise for status and return the response dot JSON, okay. Same pattern as the get client card one, get raise an error part the JSON, same it is. After that we have this async def poll until complete, right. This is for self, okay, task ID str, we will have initial delay evaluate equal to 2.0. alright. So why we are doing this is we will start awaiting by waiting for 2 seconds before first check, right. Don't check immediately. The task just started and definitely isn't done yet, so save one unnecessary HTTP request for here. So initial delay will be this, and after this max delay is a float type of 15.0 15.0, right. So never wait more than 15 seconds between the checks, right. For very long task 50 seconds is a reasonable max poll interval. So yeah, we will define a max attempt also is equal int equal to 60, okay. So you have to give up after 60 attempts with exponential back off. This means that we wait approximately like 2, 3, 4.5, 6.7, 10, 15, 15 plus, like this. 16 attempt up to a 15 minutes of total waiting, right, time. Alright, we will approximately we will wait for 15 minutes with this max attempt will be 60 with the back of time on progress. Okay, optional callable, okay, equal to none. So optional callback function for progress reporting, right? So if this function is provided, so this function is called on the every poll. It is useful for showing the live progress bars or logs updates in a UI. Okay. All right. This is the function we have. Direct tr comma any. All right. We have delay is equal to initial delay. Okay. To start with the initial delay here, and this variable changes each loop iteration with the exponential back of grows it. Okay. And we have this terminal states. We define them manually. Equal to we have these states, which one is task state is completed, right? This is one. Then other one is task state is failed, right? Then it has task state is cancelled. Alright. So a Python set, okay, it's a set, not a list of states where the task is done. Okay. Why we are using set here? Because state in terminal state is order of 1 for sets versus order of n in the list. Okay, so we can check. Okay, it is not critical here because only 3 items there, but it's a best practice to use it, right? So why we are using all 3? Because this task will never change state again. Okay, like stop polling when any of these state reached. Like if it is completed or failed or cancelled, then we don't have to poll, right? And this is what for attempt in a range, right, of max delay. Alright, wait a minute. This is the max attempt range. We have to await dot async IO, right, sleep for delay, whatever delay is, we have delay initial delay for now. Okay, for 2 seconds, right. It will delay for this time. Wait before each poll attempt, and what it does is suspend this routine for delay seconds, which is 2 for now. And during this time, the event loop runs other coroutines. And why we are waiting first? Because we said delay is equal to initial delay before the loop, right? So we wait before the first poll 2. So this is intentional because the task definitely isn't done yet in the first milliseconds, right? So that's why. After that, we have task data, so is equal to await self or to get task status with task ID. Okay, Then this will actually check the task status. What it does is it get the status of task, and with the HTTP get request get method, right, return the full task dictionary with the current state. So let's extract the state from here. State from task data, status, state. Okay. This will extract the state from this. Is it task still working, or etc. like this? We extract the message from it. Message is equal to task data and status dot get message. Okay. Why we are using this? Like dot get message is simply returns if message is absent, right? It will return the empty string. So this will not generate any error. Okay. Then after that, print f string with A2A here, A2A client, right? All attempt plus 1, alright, slash max attempts, alright, state is this, message is this, alright. We give the whole information now here in the print message. If we are using this on progress, okay, then on progress it will save us the var state message, okay, task data. Alright. For the progress callback, if one was provided here, it lets the caller receive live progress updates, right? Example, the orchestrator might update the UI progress bar here. Okay. If state, alright, if state in terminal states, right? So if state is there, equal to task state is like, let's say it's completed, right? Completed. Then what it will do? It will return task data. Okay. Elif state equal to task state failed, right? If it is like that, what it will do? It will return. It will raise something, runtime error, and it will pass like a research task failed, and it will give the message of message, right? Whatever message it get from the task data, right? Else it will raise the runtime error again. It will say, okay, research task was cancelled, right? Okay. And after all of this, we will update the delay will minimum of delay into 1.5 comma max delay. Alright, we will update that. So why exponential Bake-Off? The critical algorithm is there because what it does is multiply current delay by 1.5 but cap at the max delay right here. Okay, cap because we are using the minimum here, right? Like it will go from 2 to 3, 4.5 like that. Okay, and why only multiplying with 1.5? It's a industry standard. AWS uses 2x and we use 1.5x for slightly more frequent polling. It can be adjusted based on your needs. And why this matters? Because 100 concurrent tasks polling every 2 seconds, 50 requests per second. So with Bake-Off they spread out over time, right? And if nothing was working, right, and all of it after that, after this for loop it will raise timeout error, right? Because task ID, this task did not completed, right, after max attempts, right? After all this, let's define a function which is async def stream task, right? Self text str, alright, async generator dict comma none. Let me explain it what it is doing. So it is alternative to polling, right? It will receive live updates via ASIC streaming. So an async generator function, caller uses it with the async for event and client stream task, right? Each iteration yields one SIC event dictionary as it arrives from the server. So in this, what we will do, URL is equal to f string of self.base URL, right? And slash v1 slash message stream, right? Stream is the A2A streaming endpoint, right? After this, we define payload is equal to this. Here we have message, right? We have this message ID str, which is UUID.UUID4, right? And it's str, guys. Okay, and we have this role also. Role is user for now. It can be model also. We have parts. Okay, we'll have text, right? After all of this, why no blocking field here? Because the stream endpoint is inherently non-blocking. By nature, you don't wait for the full response, you stream it right after that. And again, we have again async one more method with self dot client order one. Alright, right here dot stream. Okay, then we will use this post URL JSON equal to payload, right, as response. Okay, it will stream. So why we are using async with HTTP stream is a context manager. Okay, what it does is open the HTTP connection that stays open while the server streams data. Okay, async with. Why we are using this async with? It shows that the connection is properly closed when we exit the block, success or error. Okay, so post plus URL makes an HTTP post request to the streaming endpoint. Alright, and if there is any response error, so reach for status, it can give the error status. Okay, then async for line and response dot iter lines. Okay, why we are using this is it will iter over the response body line by line as it arrives, right? Iter lines does what it does. This is it returns the async generator that yields one line of the response at a time. Okay, and each line is received. SS events are separated by /n/n, and each point, each event line start with the data dot iter lines handles the lines splitting for us. Okay, so after this we check. Okay, if line dot start with data, okay, like this, then because why we are using like this, because SSE format sends each event as data / JSON. Okay, data colon and then JSON. So we only process lines that start with data colon. Other SSE lines like events ID can be ignored here. Okay, after this we will try here. We will have event data equal to JSON. Okay, dot loads line 6. Why strip the data prefix 6 characters? Because data, then we parse the remaining JSON. Okay, because data slash 1 2 3 4 5 and 6, these are the 6 characters we parse after this. Okay, we parse the remaining JSON. Okay, what JSON.loads does is it will convert the JSON string to Python dictionary. Okay, after all of this, we will yield event data, right? Why we are using yield here? This is what makes the stream task a generator, right? Each event data dictionary is yielded to the caller immediately. Okay, the caller's async for loop receives it for right away. After this try, we will have accept, okay, accept json decoder error, alright, and continue. Why skip mail form SS event gracefully? Because what continues does is skip the next iteration of async for a line, ignores the bad line. Okay, it will ignore the bad line. Alright, after all of this, alright, now we have async dev with cancel task. Okay, we can cancel task also. Self task id str bool is the return type for this. Alright, so what we are doing, guys, let's we are implementing the cancelling task, right? Okay. It will allow aborting a task that no longer needed. It will use the HTTP delete method. The server marks the task as cancelled and stops processing it, right? First, we need the URL for the delete one. To delete the task, we need URL for the task. Float base URL, which is /v1 /tasks /task ID, right? Alright, and after this will response is equal to await self.client delete, right? Rel and why delete? Delete is the REST standard for deletion or cancelling, right? And then we have this if response dot status code, okay, is equal to 200, right? Then parent, in this case task ID is cancelled, right? If it is not 200, and return true, alright, else it will return false, right? After that, we will define a function which is async artifact in artifacts, right? Loop through all the artifacts. There might be more than one, right? So parts equal to artifact dot get parts. If it is not there, so you go empty array, right? Or empty array. What happened in this? Okay, so this is like def, right? Wait. Oh. Alright, before anything, guys, because I think I messed it up, we will have async def get result artifact, wow, wait, async def get result, right? Result text, right? It will have self, it will have task data of dictionary str, then it can have any type of in here, str is there. After this it will have this for okay artifact and artifact. Alright. Before of anything, it will get this artifacts is equal to task data not get, right, artifacts or empty. Alright. After this we will have this for artifact and artifacts, then parts, right, where just a minute. Parts is equal to artifacts and parts, artifact dot get, right, then for part and parts, okay, if part dot get is there, any text is there, right, it will return part text. Alright, return the first text we find, and if it is anything it will return empty string if it is there is no text, right. After this we will define a research async ref research, right, self, alright, then topic which is str, use streaming, okay, streaming, and its goal is equal to false strs. What is this? It's a high level convenience method that the orchestrator actually calls, okay. What it does is it hides the complexity of submit, then poll, then extract, everything, okay. Orchestrator doesn't need to know about the task ID, polling and loops, right, or artifact extraction. It just calls results, my topic, and waits. So for this it will use all of this, it will do all the work for orchestrator, right. Use streaming report parts is equal to empty for now, then use streaming is shows the live progress, use when the wants to display what the agent is thinking in real time, right. Report is parts like it will collect result chunks from the stream, and async for event in self dot stream task topic, okay. It will add it through SS events as they arrive, and after that event type, right, is equal to event dot get type, okay. After that each event has a type field like type field and progress and complete and error, like all of these fields, so we can get that. If event type, right, is equal to progress, right, then state is equal to event dot get status. If it does not get, then empty dot get state of that. Alright, if it is not, then return empty here, and we will have partial equal to event dot get partial text. Okay, if it is not there, then empty string. Alright, then print f as string state. Alright, partial 80 alright. So it will shows live progress to the user or developer. Partial 80 is using because the shows the first 80 characters as a preview, right? Then we have elif if event type is equal to complete, right? Then it will get the artifacts is equal to event dot get, right, artifacts, or it will give a empty array for artifacts fact in artifacts, right, for part in artifact dot get part. If it is not there, or empty array. If it is like this, report parts dot append part text, right. Extract all text from the completion event artifacts. Okay. Alright, and we have this done, and all of this for loops. Elif we can print like, okay, A2A to A client streaming, okay, complete after all this, and we can break from here. Alright, then elif event type equal to error here, right, and we raise runtime error. The streaming error is there, right. Event dot get status. Okay, then after all of this we can return /m dot join report parts. Okay, else we can go for like this. If it is not streaming, then we have to poll it, right? So polling approach, simpler, no live updates, just wait and get results. So like this, task ID, right, is equal to await self dot send task. Okay, we are polling here of topic. Okay, submit the task. It's non-blocking, get task ID back immediately, right? Then it is def progress callback state message and task data, right? And this we print f is like state message. Okay, simple callback that prints each poll result, and we define it in line because it's only used in the next call. Okay, so after this, final task is equal to await self dot poll until complete, right? And this we provide task ID, and on progress is progress callback, right? Done. It will show the live update. Return await self dot get result text. It will final task. Okay, it will return this. Extract and return the text from the complete task artifact here. Here we will show the progress in console. And after all of this, guys, we have this async def close for self. Alright, self. Why always call this when done with the A2C client? Because what it does is it closes the underlying HTTP async client, which closes all TCP connection and freezes the network resources. Important, not closing causes the resource leaks if this client is used inside the async function. Uses it in a try and finally block, try finally await and client close, right? Then await self dot client dot a close. Why a close, not close? Because HTTPX async client uses a close for async closing. Regular close would block the event loop. Next, we will guys think what? Alright. So next we will do this file. Not now because This is my sleeping time, guys. I am going to sleep, and after this we will. This is the last file, one of the last files. We will code this tomorrow. Thank you so much for joining me, and we will get back. Okay, thank you.